So what we were doing is the relative motion, and the last topic that we discussed in the last lecture, that was uh, the river boat problem. And in the river boat problem, we saw the two basic concepts. And the first was line of heading, and the second was line of motion. So the line of heading and the line of motion are two different velocity in two different frame. Now the line of heading represents the motion of the swimmer or boat in the frame of water itself, or is to be more precise, water surface. Line of motion was meant for the ground frame motion. So how the swimmer will be moving as seen by the person standing on the shore or the bank of the river is called the line of motion, or you can say the absolute motion in the ground frame. But the line of heading was motion in the frame of water itself. So for any observer who himself is moving along the flow with the flow velocity itself will only witness the line of heading. Okay. So this is what we did. Let's create a river. So now there are few things which will be asked to you. So for the purpose of analysis, we will take the the width of the river as the y-axis, and along the direction of flow as the x-axis. So I'll prefer taking this as the x-axis. Maybe I can extend the line of it. Yeah. So let's call it y-axis. Let's call this as x-axis. This is the x-axis, and definitely the flow river is the flow velocity is towards right. Let's say along the x-axis. So if you remember in the last lecture, I said to denote the flow velocity, we will be using the symbol u. Okay, and let's say the ability of the swimmer or the boat is v, and the swimmer is trying to move this way. So I'm saying that the flow velocity of the swimmer with respect to the flow direction is theta. So the theta we will call what? Line of heading. So this direction is the line of heading. So what is the line of motion? How to find the line of motion? So the line of motion is determined by the resultant of the v and u vector. If this is the u vector, let's call this as u vector. So we have to complete a parallelogram. So let me complete a parallelogram. And this is the resultant of the two vectors. And if you extend this line, then what you will see is called the line of motion. So this black line is called line of motion. And if I make one more line, probably to show the V, then this is called line of heading. So it is very easy to understand the two concept, the line of motion, which is the resultant of U and V. This is called velocity of the swimmer, you can say, or man, whatever. And as I said, the V actually represents velocity of man with respect to river, and U represents velocity of river, and Vm is the velocity of swimmer with respect to ground. So these two concepts are very important. So now we can also solve this question in terms of component, the way we do for normal kinematics. And if you look carefully, these questions are questions based on the constant velocity. So there is no acceleration term. One more variable that I need to introduce is the width of the river, and we will keep it constant called d. So our river will not be random shape; it will be like a rectangular shape only, and the width will remain constant and will take as d. Now, because this is the shape of our river, okay, this is the shape of our river, and there are few questions that they will ask you. Before you solve any question, let's try to learn how to write the x coordinate. If I say this as origin, so x coordinate, how we write as ux into t at any time t. And what about the y coordinate? Uyt. So in general, what is ux? So for the given situation, what is ux refers to? So ux is referring to this value. If you draw a perpendicular from here to the bottom, because this is the resultant velocity, and if you drop a perpendicular to the bottom to the x-axis, then this length, the entire length is the ux. So this is your ux, and this is your uy. So tell me, what is ux? If this is theta, this is also theta, and if this is v, this is also v. So the ux is obviously how much? Tell me, guys. So it is u plus v cos u. So u will be there, and you can take the component of v, add these two together, you get the ux. But what is uy? What is uy?
V sin theta.
Pardon?
V sin theta.
Yes. So it is only v sin theta. So now what you can realize that the movement along the x direction depends on both velocity, that is the ability and the flow. But crossing the river, the velocity which is responsible to let you go across the river is totally independent of the flow. It has nothing to do with the flow. So the time taken to cross the river depends only on the y component. So this is a very common question which you will face, that how much time it will take to cross the river. So time taken to cross the river. So when you cross the river, then what you can say? What is your x displacement when you cross the river? Do you know the x displacement when you cross the river?
No.
Do can we say the y displacement when you cross the river?
Yes.
Exactly. So the y displacement is known to us. Delta y is how much? D. And we all know the formula for delta y, which is uy into t. Here, delta y is y only because this is basically delta y. But the beginning was origin, so delta y. So now if we just substitute the value, we get the answer. So let's call it capital T because we have crossed the river. So the time taken to cross the river is a very simple formula, d by uy. Now uy will change from question to question. In our case, it is d by v sin theta. So now the next question they will ask you, what is the minimum time to cross the river? So what should be the line of heading which will let you cross the river in the least time? So for t minimum, so we can see the denominator is sin theta.
Perfect.
Yes. So for t minimum, theta must be 90 degree. That is, the line of heading must be y-axis. So we say that line of heading must be y-axis, and in such case, the t will be just t by v. So now this is called the line of heading. Now, when you cross the river, will you be on the opposite bank or somewhere drifted away from the opposite bank? So we can see clearly that when we cross the river, we are not as expected. We are not here. So we are somewhere here actually. So when you reach the opposite bank, you will find yourself here because that is the line of motion deciding. So this is called the x displacement or displacement in the direction of flow. And this term we call it drift. So you have been drifted away. So you have been drifted away due to the flow, partly due to the flow and partly due to your own velocity component. So they will ask you find the drift. So this is a very common terminology in relative motion in the river boat problem, finding the drift. So calculation of drift. So what is the definition of drift? It is the displacement along the flow during crossing of river. So it is displacement along the flow during crossing the river. So basically it represents the x value. Xt we can attach ux into total time t. So now what is I mean what is xt here? What is ux? It is u plus
U plus V sin V cos theta.
v cos theta and t was d by v sin theta. Like in general we are writing. So this is the drift for the given situation. You can minimize it. So the xd, if you multiply both the terms, you get ud by v into cosec theta. Because sin theta we have can write as 1 by sin theta is cosec theta plus d cot theta. So now, just like we found the t minimum, the other question is how to minimize the drift. So for xd minimum, we must choose some better line of heading. So theta is a
45
variable,
degree.
so we can write as dxd by d theta equals to 0. So can you differentiate and tell me what you are getting as theta? Can you do the differentiation? Yes or no?
Yes, sir.
Okay, so do it.
So we have to find theta value also.
So when you're differentiating, after differentiating, what are you getting? Okay, let me do this. So
Sir, I am getting minus d.
minus cosec theta into cot theta, right? Plus
Yes, sir.
d minus cosec square theta equals to 0. And now if you rearrange, because this cosec will common one, cosec will cancel, d will cancel out. So minus u by v cot theta is cosec theta. So u by v cot theta we can attach cos by so the cos theta turns out to be how much? Minus v by cos theta is v by sorry. Yeah, v should be in the cos theta minus cosec into cot, and cot is minus cosec square theta. That is correct. 1 by sin, sin cancel. Or maybe we should not cancel sin. We should take something common. So 1 by sin theta plus u by v cos theta by this will not work. Differentiation is not working, so there's some problem with differentiation. Cos theta is minus v by v by no, v by u is not. Even that answer is okay. So it says that minimum drift to 90 plus something u b by
Sir, I got the answer of theta.
how much?
Sir, last.
No, you got the answer, but that answer is actually wrong. That's a problem. The answer should have been by v u by v, and what we are
Sir, I
getting is
got that
u.
only.
Yes, tell me how.
Sir, I got cos theta is equal to minus v by u.
Yeah, that is correct. So what is the mistake here?
What?
Cot theta. U u plus v cos theta. That's correct. D by v sin theta. So can you see the mistake here in calculation? So differentiation of cosec will be how much? Minus cosec square theta? Minus cosec into cot theta, right? So when you differentiate by theta, what do you get? U d by v, which is constant, and cos theta will give you how much? Minus cos theta into cot theta, and cot gives minus cos theta. If I make this to 0, you can take d cos theta common. So what you get is minus u cot theta by v minus cos theta. So u by v cot theta is cos theta. How are you getting it? Can you
Sir,
show me
may
how?
I send you the?
Yes, yes, send me.
Sir, I differentiated that up one u plus v cos theta into d by.
Mhm.
Sir, but I'm getting the similar answer which you're getting, sir. Minus u by v cot theta is equal to cosec theta.
Yeah. I know that this is wrong, but the problem is why mathematics is not giving us, because I can get the answer, of course, in many ways, but this should give the answer. So what is the problem with the differentiation? I'm like still trying to figure it out. There is some common problem with this. So this is 0. I mean, in fact, the t should not matter. Okay, it's like to make the diff 0, we can just make this 0 because time cannot be 0. So the only way to make
Sir,
0
I
is
sent you.
the first term we can make it 0. But it should also come with differentiation. Hmm. You are getting the same answer, the same thing. You're getting cos theta equals to v by u, right?
Yes,
This is the same thing we're getting back.
minus v by.
Minus v by u. Yeah. So this is what we are not supposed to get actually. That's the problem. So we are supposed to get u by v. And that's why I'm saying. Oh, okay. So this is okay. We can do it without, of course, we can do it without this. So for D minimum, this is also in a way correct answer, not wrong, but this is meant for something different. This is actually trying to minimize the drift, and what we are trying to do is to make the drift 0. Okay, so the easy way, okay, let me go the easy way. We do not need differentiation. We will come to this also. This will be helping us in solving one other part. So this answer is also correct. I got the why we are getting this problem. Xg, we can look at the first expression. Xg is u plus v cos theta into some time. Now to cross the river, that many condition that is the flow velocity is greater than the swimmer's velocity or vice versa. So we can take the case 1. If the man can swim faster than the river flow, that is, if V is more than U. So in such scenario, to make drift zero, the only way is the first term must be zero because second term cannot be zero. And we can see it's a product of two numbers. So basically, the two factors U plus V cos theta into D by V sin theta, this is zero. Now we know that the second term cannot be zero. So this cannot be zero. So the only way to make this zero is the first term must be zero. So U plus V cos theta must be zero. And therefore cos theta terms are to be minus U by V as expected. And because cos is negative, so theta must be in the second quadrant. So theta we can write as 90 plus cos inverse U by. So this is the angle that you must make, which means if I denote the x and y axis again, so instead of heading towards right, you must head this way, and this is the angle. So if you head this way, then you will exactly reach here at the opposite bank. So that is the case. But normally we don't solve this way. So what I'm trying to demonstrate here is how to do things only mathematically without thinking much about the realistic situation. But these problems are pretty easy if we actually try to go back to the diagram and then try to solve. So let's go back to the diagram and try to solve the same.
I want to see, sir. I want to see the previous, the first slide.
So differentiation will not work here.
Yeah, differentiation is not required here because this is the obvious thing. And differentiation is not giving wrong answer, but it's giving for the case 2 when the flow exceeds the man velocity. So in that case, that will work. Okay, this is done. So we are taking the case when the man can swim faster than the river. So in, of course, in such case, the answer which we are getting will not make sense. And therefore, to make sense out of this, we need to do it differently. So now imagine you have the river, same river. Let me draw a small river now, not to occupy the entire space. And this is your y-axis. This is your x-axis. Maybe we should put it here. Now, what is the meaning of crossing the river without any drift? So I'm still taking the case when the man can swim faster than the flow, and the flow I'm taking this way. This is U. Now, to cross the or to cross drift to cross without drift or to reach the exactly opposite bank. Now, if you want from point O, and if you want to land exactly here, then what should be your line of motion? The line of motion must be along y-axis. Why? Because we do not want any drift. So we do not want to be get away by the flow. So someone is starting at O must land on the opposite bank. But if you try to go this way, the line of motion will take you somewhere here. If you try to move this way, then definitely the line of motion will be like this because the flow is towards right. So to cancel the effect of flow, what you will do? You will try to tilt opposite. So when you try to tilt opposite, then you can cancel the effect of flow. So to solve question, generally what we do is we take the v at an angle theta with a vertical like y-axis. So the particle will have two velocity, one towards right, which is due to flow, and the other is as I have shown. And the resultant of these two vectors must be along the y-axis. So what we are expecting is that the resultant of these two vectors must be along the y-axis. Then only you can exactly reach the opposite bank. So the rule is if you know where you want to land exactly, then the resultant velocity must be in that direction. So the rule is simple. If you know the line of motion, so the thumb rule says if you know the line of motion, then resultant velocity in ground frame must be along the line of motion, or in other words, net velocity in the direction perpendicular to the line of motion must be zero. Now, if y-axis is the line of motion, if y is the line of motion, then the velocity in the direction of perpendicular to this must be zero. So but we can say that u and this is v sine theta. These two will balance out. That's why you will go this way. So we can say that for zero drift, v sine theta must be equals to u. It's the same answer as that we got earlier. But earlier the theta was from the x-axis. Now we are directly getting from the y-axis. So we have the 90 degree is not appearing here. And also I have changed the theta from vertical than horizontal. So the cos has become sine. So this gives the obvious answer that sine theta equals to u by v. But this also says something interesting, that any sine or cosine function is always from the lies from the -1 to 1. So it must be a fraction. The u by v must be a fraction. This must be less than 1. And that is only possible when v is more than u. So that condition is necessary to think of zero drift. If this is not the case, then we cannot have zero drift. So it's impossible. So if the sine theta turns out to be more than 1, then the meaning will be it is impossible to have zero drift. Okay. So now because sine theta we got u by v, so how much time it will take to cross the river? So time taken by swimmer to cross the river. Time taken by swimmer to cross the river. Uh, for zero drift condition. So we can write this g equals to how much? The width of the river. So how to write the time? Tell me, guys. The y value upon the vy, right? Uy. And what is uy here? V cos theta. Now the theta is known to us because sine theta we know, so we can write as v, and cos we can write as 1 minus sine square theta. This is how what we do always. And now you just substitute the value of sine theta from there. It turns out to be v square minus u square under. So you can see that if you want to cross the river in the minimum time, cross the river in the minimum drift or zero drift actually, then time will increase actually. You need to travel a lot. Now there are many ways of thinking about the same problem. This is one way of thinking. The other way of thinking is, so let's say this is our river. This is our river. Now let's change the color. So in the water frame, we know the flow will take you towards right. So to use the advantage of the flow, let's say it's very simple. You want to reach opposite bank. So you know that if you travel this way, and if there is no u, let's say in the river frame, you try to reach here, and in the time you reach on the this location, the river will take you from here to here. So in time t, if we ignore the flow velocity, in time t you must have traveled v t, and in the same time the river has taken you ut, and that is why you have traveled exactly at the opposite bank. So everything is obvious from this triangle. You can get the answer in one line. So you can use the Pythagoras to get the answer. So you can say Vt whole square equals to Ut whole square plus G square. And this, if you solve this, you get the answer. And also you can see the sin theta is u by. So all answer we can derive from here directly using the Pythagorean triangle. So reaching the opposite bank is like creating this triangle. That's it. So you move Vt in the frame of water. Water lets you move along the flow by Ut, and the resultant vector is here. So this is how we can answer. Okay. This is one way of thinking as well. So now we'll take the case 2 because that is a challenging situation. This you understood?
Yes, sir.
So now the case 2 is important. What happens if the suddenly the river flow becomes very high, which normally is the case during the flood situation or near the origin of a river where the water is coming from the Himalayas and flowing down the the plane. So before it reaches the plane, it moves very fast. So let's say if you go to maybe Haridwar or Rishikesh, the water flow is really high and there is a slopy path because the water is still going down. So that's why the river rafting is very famous in Rishikesh in India. In fact, it is best known for river rafting. Now, as the water reaches the maybe Delhi, which is a plain area, the speed will decrease a lot. Anyway, that is not our question. Our question is, what happens if you exceed v? Now, if u will exceed v, so in the time you will travel some distance vt, the ut will travel much more than that. It means if I do use the same diagram, in the time you reach here, the ut will be somewhere here. So, however hard you try, you must have some drift. So this part you cannot ignore. So the drift cannot be zero in this case. In this case, we cannot have zero drift. Now the zero drift condition is gone. Why? Even if you move exactly across the river flow, because the u is this way. Now this is the u vector. Even if you try to just swim exactly opposite, because u is bigger than v, so net will be towards the right one. So the x component now cannot be zero. So whatever situation. Imagine if you try to cross the river, I'm just changing the color now, and it is impossible to make the drift zero, but we can minimize the drift. Now that's interesting. So when something is not zero, we can at least keep it minimum or the lower value. And for that reason, you will travel this way, of course. Now the question is, what angle will reduce or minimize that drift? Although we cannot avoid it because u is much bigger than v, but at least we can minimize it. So what we can say that ux will be u minus v sine theta because we cannot make it zero, and uy will be v cos theta as usual. So you will have some x value. So the drift will be equals to ux into t. Now, as I said, we cannot make the drift 0 because ux cannot be 0. So now u minus v sin theta, I cannot say that this term is 0. Can I say? I cannot say this term is 0. Why? Because the u is bigger than v, so u is anyway much bigger than v sin theta, because sin theta when will be multiplied with v, it will make this term even smaller. So u will become always bigger than v. So that first term I cannot equal to 0 as I did in the previous case to make the diff 0. And that is why the 0 condition is gone. So what we talk about is called the minimum condition. So let's multiply this. ud by v sec theta minus d tan theta. Now going next, so we are actually going from here to here. This is the flow direction of solving question. So for x minimum, x cannot be equal to 0, but we can minimize it. For x minimum, the dx by d theta we can put it 0. So there must be some angle theta which can allow me to get this. So the x minimum we can differentiate to 0, and if you do so, what you get? So you will see that ud by v sec theta tan theta minus d, and now d sec theta will cancel out. What you get is u by v sin by cos 1 by cos cancels, sin theta equals to 0. So here sin theta turns out to be v by u, which is logical because u is bigger than v. Now this will be less than 1 for sure. So the angle formula we have got earlier as u by v because v was bigger, but now we are getting v by u, which is making sense also. So now if you put sin theta equals to v by u, then you can get the minimum drift, which is not 0, of course. So let's try to find the minimum drift value. The minimum drift value. So x minimum is u minus v sin theta d by v cos theta. Let's substitute the value. U minus v. What is sin theta? It's v by u as we derived. What is cos theta? 1 minus v square by u square. So it turns out to be u square minus v square by u into d upon v into u square minus v square upon u. Now, of course, it cannot cancel out. So, what we will get here? No, this will cancel. What we can get here is under root of u square minus v square d by v. Or to be more precise, you can actually. So this is the x minimum.
So can you show the last page?
So I'm writing flood situation just to make it realistic.
Send answer.
Okay. Okay. So now you got the x minimum. So you cannot avoid the drift, but you can minimize the drift. So in this scenario, when you will reach the opposite bank, let's say if you reach from here to here, although you have tried to move this way, but because u was bigger than, so the resultant of these vectors, if you try to understand the vector form, this is the resultant velocity of u and v, and therefore you have reached this system. And here we got sin eta equals to v1. So this is the scenario. So you reach here. Now to, let's say if you can walk on the shore with some velocity, so it's normally this question is given. If you want to reach the opposite bank, then let's say you can walk on the shore with velocity v naught. So velocity with which man can walk on the shore. If that is the case, if you can walk, then to reach, then to reach the opposite bank, with minimum drift condition. Now try to understand, I'm writing minimum drift condition, not zero drift condition, which I used to write earlier. So what we write is the total time elapsed. Total time elapsed equals to the time to cross the river plus x minimum by velocity of walking. So the t we got as d upon v cos theta, which is u by v into u square minus v square, plus x minimum by v naught, which is u square minus. So this is the answer. You can set t in total. Now this is the question from IE Irodov. So I have solved the entire question of Irodov as a theory. So this is your theory. Now I'll give you something very interesting. Like, can we solve this without using calculus? Can we solve it mentally, or maybe just by using graph? So now you will learn the power of, like, triangle law, or the vector method. So let's try to do the same thing without, you know. Okay, so let's see how we can do it.
Sir, I want to note that last sentence.
Just
Hello, sir.
yes.
So the 7 questions you said to solve. Sir, that questions, if you have doubt, then we have to ask in the tutorial. Sir.
Yeah, yeah.
Yes, sir. Okay, sir.
So now,
Done, sir.
yeah. So this is now something very interesting we are going to see. How every question we can just solve by the vector. So let's say this is your river, and we'll go back to the same technique. So the v vector, sorry, the u vector is bigger than v vector, right? So that's the thing which we know. So this is u vector. Let's say make it as big as possible. So the v vector we can draw from the tip of the u vector, because what we know that v man is u plus v, right? This is what we know. So this is like a triangle law in which from the tip of the first vector draw the second vector, and then the resultant is this, right? Are you getting a point? If this is u, this is v, then this is the vm, and it is the vm which will determine the line of motion. So vm, sorry, the v can have any direction. V can be like this because it's small. V can be like this, like this, like this, like this, like this. Okay, not like this. Okay. So what is the possible direction of v? It can be in any circle, any point on the circle. So if I draw a circle at the tip of the first vector, and if the radius of the circle is exactly as the what? The length of v. So the v vector can be anywhere here. Are you getting my point? What I'm saying?
Yes,
So
sir.
now the question is how to minimize the drift. So the best way to, okay, if you are here, let's say if you're here, then the resultant is something like this. So you will end up reaching here. Can you see this? You will reach, oh my God, somewhere. So to minimize the drift, the only way is you must travel along this tangent, right? Okay, I think you have no connection. Anyway. Okay, let me make
Sir,
this
it should
connection.
be inclined in the left hand side portion.
It bigger, not big enough, but at least bigger. Yeah. So the idea is the only way you can minimize the drift is if you can go along this tangent. So the if the resultant is like this, then you will reach here. This is the minimum value. For any other value, it will be more than this, right? So if you take any other point on the circle, if the velocity is not this way, if I take v exactly like this is u, this is v, so we can say this is vm, and this is the only vm which is minimum. Can you realize this? For this vm, the x will be minimum. The difference is minimum. Do you understand this is minimum? No. If you take other angle, what will happen to the vm x minimum? Will it increase or decrease? Let's take some other value.
So it
Let's
will
say this,
increase.
it will go like this, so it will increase definitely. So the minimum drift is only possible when this is exactly perpendicular, like tangent to this, and that's how we solve the question. So our job is done. So we were looking for the angle with vertical. So let's say this is easy now because we can draw a vertical line. So what is this angle? Let's call it theta. If this is theta, then this will be 90 minus theta. So this will be, and therefore we can directly add the answer. What is sin theta? V by u. Can you see that? Then, so without differentiation, we got the answer. Okay. And if you travel here in time t, So this must be Vm into T, like this is. So what is the X minimum? This you can understand. The X minimum turns out to be Vm T cos theta. Can you see this? So now question is, what is Vm? So Vm is U plus V vector. So to find the Vm, it's very easy. If you look at the velocity triangle, UV, can you find Vm? This is Vm. It turns out to be under root of U square minus V square. And then T we know D by V cos theta into cos theta. Oh, this cancels out. So answer becomes U square minus V square D by. So what is the answer? If you go back and check. Yes. So now you can see that you can do all of these questions. Okay. So you understand what I'm saying. So it's very easy to solve the question using the vector diagram, but it's very difficult to master this process. So if you do more of the vector thing, then probably you can do this. Else you have to go through the basic mathematical way, and that is not bad. That's also good method.
So the T cos theta, how it came?
We are taking this triangle. So this length, the entire length is.
Yeah,
I'm
sir.
taking this triangle, this triangle. So VMT cos theta is x minimum, right?
Yes, sir.
That is what I exploited. And see, we got all answers in, and you can actually in fact apply the same thing for the previous questions. I can tell you the previous question how to do it graphically. Maybe if I have some space, I can do it. I have space. Oh, okay. In our case, the V is bigger than U. Okay. So, okay. Let's say this is U, which is small, but the V itself is bigger. I can draw a V exactly like this because V is bigger than this, and therefore the Vm will be like this. So for minimum drift, if this is U, this is V, I can take V like this, then this is Vm. And so my job is easy. So we can actually have the zero drift. So to find the angle that V makes with vertical, all this angle theta, because we can directly get the answer. So what is sin theta? Uy. So see how easy is to find the answer. And the Vm will take you exactly along the opposite bank because V is more than. So that is the power of vector method. Like we can do it mentally most of the questions, but I'm leaving it up to you to practice this particular concept and try to incorporate in solving various other problems. So that's your skill which you need to develop. Okay, I'm giving you the exposure, and you can capitalize on this idea as you progress in your course. So that's your job. My job is over. So now we are going to deal with something last two variety we are left with. Hopefully we should be able to finish. So this is called wind and plane problem. Now this is again interesting to understand that the plane never moves with respect to ground. So the ability of a plane to fly is always with respect to the atmosphere or the air or the wind. So the birds or the plane or helicopter, except the rocket. So these things fly with respect to air. So air is the essential ingredient for them to fly. Without air, it's difficult. Now, if you go to very high altitude, the air pressure will drop significantly. Now, when the air pressure will drop significantly, then a helicopter cannot fly to greater height. That puts the limitation on a helicopters. So we use the Indian Air Force fighter planes because they move so fast that they do not require much air. So they maintain the air drag requirement using their speed. And they also have a rocket-like propulsion called the exhaust. So the aircraft will create some sort of fuel burning, which will release the exhaust from the back, and that will propel forward. So aircraft planes manage with thin air also. That's why at a very height we need the fighter planes, not the helicopters. Okay, so that's one reason like how we decide that's why in during war, if you are fighting war at very high altitude, then someone will be at advantage. So you cannot use your helicopters, but you have to call for the other things. Anyway, that's there. In the wind and the plane problem, what we need to do? So let's take two airports. So the first airport I'm putting at the origin, and let's call this as y-axis. This is x-axis, but I will say it's east. Let's call this north. This is the horizontal graph, not vertical. The the destination or destination airport is somewhere here. Let's call this is Delhi Airport, Indira Gandhi International Airport, and this is the Chhatrapati Shivaji International Airport. So you want to go from here to Delhi, and you are the pilot of the plane. So now the destination is known to us. So the first thing you need to realize that this must be your line of motion. This is your line of motion. Because in case of airport, we cannot afford drift. If you land somewhere here, it will be dangerous. So you are supposed to land only on the runways, and therefore the line of motion is the motion joining the two airports. We're taking that. So let's take a scenario when the wind is also present and it's very high speed. So at altitude, the wind speed also increases because there is no obstruction. But still, the wind speed is very, very small compared to the plane velocity. So that's not an issue. So I'm calling the wind VW. We call it velocity. Now we call something called velocity of plane with respect to wind. So velocity plane is always defined in the frame of wind, and we call it V. Now the direction of V defines the line of heading. So imagine if you want to reach here, if you try to move this way, what will happen?
Sir, you would land right hand side towards the airport, like
You will actually go this way. This is not like a thoughtful decision, so it's dangerous. So what we do is, so we need to think of the line of heading something like this. Why? So that because now the plane is actually very large, so I have done something big. The V wind is very small compared to the V plane. So the two together, the velocity of plane, which is this way, let's call it VP. VP is the better way. And this is VPW. So we are writing VP. Uh, Not this is VPW. So let's only call V. That we get confused. This is V, not VPW, because VP means, so VPW is what? VPW we can write as VP minus VW. So velocity of plane in the ground frame will be VPW plus VW. And I'm calling this as V. Let's keep it V and U as it. So let's call VW as so that I will stick to the same definition. And this is your VP, the resultant of these two. Okay. So anyway, this direction is called line of heading because the VPW always represents the line of heading. Just okay. So now, how to solve question in case of plane wind? Here, the wind velocity will never exceed the plane velocity because it's really high. And if it happens, then okay, it will be disastrous, and no plane will land on their destination. It will be like okay, everything will go haywire. But that's not the case. Don't worry. Now, the problem with the real life is the wind velocity is not constant. So, as a pilot, the most difficult task is to understand the flow velocity and keep on shifting the line of heading to reach the destination with accuracy. And of course, it is not done manually, so they have too many sensors, which gives the idea what to do. Okay, so common sense is always used, but apart from that, there are some advanced technology which helps you. So how to solve question of the wind and plane? It's very simple. So let me draw a new just to solve the question. So as I said earlier, that if you know the line of motion, I mean, you need to remember this part. This is Mumbai, this is Delhi airport. So let's say the separation between them is D is the separation. And I'm taking the wind velocity U like this, which makes some angle here. So let's call this as maybe theta. And now the wind is fixed. Now the as a pilot, we have to decide the plane velocity. So the plane velocity must be something like this in the wind frame. So let's call it V. Let's call this angle alpha. Alpha is not known. So the rule is simple. The resultant velocity in the direction perpendicular to the line of motion must be zero. So if you want to go this way, then the other component should not exist. Which component? The component which is perpendicular to the line of what? Motion.
In our motion.
So if you resolve the V, you can see this will be V sine alpha. And if you resolve, you will get the U sine theta. So if these two components will cancel out each other, then you will only move this way. That is a simple concept which we apply everywhere. And therefore, to solve the question here, the zero drift condition is always met. So we say that to reach the destination, the U sine theta must be equal to V sine alpha. So this gives the direction in which the pilot must head its plane, and therefore it turns out to be, if I know the wind velocity direction exactly, you can get the line of heading of plane. And once you get the sine alpha, then the time taken to reach the destination will be d upon the net velocity along that line is, if you look carefully, it's a u cos theta plus v cos alpha. And this will be your answer, u cos theta, because theta is given. And v cos alpha, we can, okay, again, it's a problem. So we have to do it 1 minus sine square alpha. And if you substitute, you get the answer. So that's that's your wind plane problem. So we're done with all sorts of problems. So are we left with something? Uh, to be more
So
precise,
can you show the last page?
So with respect to J syllabus, we are done.
Done, sir.
So now, what I said is, like, with respect to JEE syllabus, we are done. But there is one particular variety of problem which is very commonplace. It is found in most of the books, including SC Verma. And everywhere else in the test series of various coaching, they introduce this question. Although this question is not asked by IIT so far. But let's learn this concept. This is called velocity of approach. or we can also say velocity of separation. It's a common terminology. So velocity of approach refers to the rate at which the separation between 2 points decreases. Nothing to do with the velocity. So the definition is V approach, the rate at which separation between 2 points diminishes. So that's what the approach. If we have 2 points, 1 and 2, let me do 2 points, just random 2 points. How they are moving, I'm not considering. And what I'm saying is that whatever way they are trying to move, and that really do not concern me, concern us. So these are two particles, 1 and 2, and how they're moving. Okay, we are not considering. What we're considering is if L is the separation, then at what rate this gap is decreasing. That's important. So mathematically, mathematically, uh, the V approach we write as minus dl by d, the rate at which the L is diminishing. That's the definition.
Sir, why minus dl by dt?
Because it's decreasing, na? So value is
So because
dl
it's
is, yeah, because dl is negative, so to make it positive, we are putting minus. So V approach is the value of approach velocity, mind cube. Okay. Now in separation, what we write? Just plus. Why? The rate at which L will grow, the separation grows. The rate. So the only difference between the two is sign. The rate at which separation between 2 points grows. Okay. So the definition wise, it's very simple. Now the question is, can we relate this with velocity? So maybe we can do this also. So right now I'm saying that this is the definition. But the next step is, can we relate this V approach or V separation with the actual velocity of the particles? And if so, then how? So let's start to understand this concept. So let's say we have two particles at some random separation at any instant. So let's say the L is the separation. As I said, L, we take L. It looks nice. And this is the two part. Now these particles are moving with some velocity. So let's call this is going this way. This is maybe going this way. Just I'm taking some random direction. Not. So let's call it the V1, V2. Let's call this as alpha. This call as beta. Now this is the actual velocity of 1 and 2. Okay. Now we can resolve these velocities along the line joining them. If I try to resolve velocity, so what we can write here now? This will be V. This is V2 cos beta, right? And this is V1 cos alpha. But we can also resolve perpendicular to the line joining them. So what we can write here? This is V1 sin alpha. This is V2 sin beta. Now tell me, looking at the component, can you guess which component will help you in diminishing the gap?
V1 sin beta.
So the sin beta and sin alpha will diminish the gap, right?
Yes.
Think carefully. Like the gap between these two particles will decrease because of which component?
X.
Can you name the component? Not getting it? Anything? Do
So
you understand the
V1
gap?
cos alpha.
Yeah. Do you understand the gap? Gap. What do you mean of gap? Separation. So we want to know at what rate the separation will diminish. So what we can say? What is the velocity of approach of these two particles? At what rate they are coming to each other?
Minus dl by 2.
So the velocity of approach is very simple answer: v1 cos alpha plus v2 cos beta. So they are coming to each other with this rate, and the perpendicular will never diminish the gap. So the v approach means simply at what rate they are coming to each other. That's the idea. And what will matter is the component of velocity along the line joining the particles one and two. So if you know the two particles, then the velocity of approach we can also define as the relative velocity in the direction of line joining the particles. So that's simple. So the V approach is this much. So also it is V parallel relative. So now there is a difference. Like we are taking the relative velocity of components, not the velocities, right? So what matter here is the relative velocity of component along the line joining the particle at an instant will give you the V approach. Now V approach and V separation is same thing. If they are going away from each other, we call it separation. Otherwise, we call it approach. And we can also say that V approach is minus of V separation or vice versa. So we can always find the V approach. If it is negative, it's separation. Is this clear? Hello. Have you guys understood this? What I'm saying?
Yeah.
So what is V approach? The rate at which you diminish. So we can say that this is basically minus dl by dt. This answer is nothing but dl. So it can have any situation. Let's say the party is going, one is going this way. Some party is going this way, other is going, let's say, these are two paths. So of course, as the particle will move on this path, the gap will shrink for some time. So imagine we have uh, two like we have two particles at some instant. One is going this way, and another is going this way. So the step one is first you join the line between the particles. Find the angle. That's called alpha. And then find the V approach. So what is V approach here? Is this clear? The V approach means the one which will decrease the gap. So only that component which is along the line joining the particle will reduce the gap. The perpendicular component will never reduce the gap. I mean, that is common sense. If it is not coming to you, then I cannot help much. So let's take some more example, then we can think of this. Imagine that one particle is going this way, and another is this moving this way. So now to find the V approach, what we need, to find V approach. So I will extend this line and let's call this angle theta. So can you tell me what is V approach here? What is V approach?
So the theta is the angle.
Sir, it's u
uh,
cos theta plus. Oh, hello, sir.
Hmm.
Sir, it's u cos theta plus v.
So I got u plus v sin theta. Sorry, u plus v cos theta. Sorry.
Why this plus? Are they coming towards each other?
Oh no, minus.
See, U is trying to approach it two. One is trying to go towards two, but two is going away. So the V approach is U minus V cos theta. Do you realize this? No. Understood?
Yes. So v u is faster than v.
See, it doesn't matter faster than V, but if the U is less than V cos theta, then it will be negative, which means it's separation. What I said is approach and separation are only different by sign. So when we find the V approach, we try to see who is trying to come. So if U is approaching to, so it's positive. But if the V cos theta is receding away, so we take it negative. Once again, the component which seems like approaching we take positive, and the component which seems like receding or going away we take as negative. Is this clear?
Yes, sir. Sir, one more example, please.
Yes, sir.
So let's take this example. So we have a square, and the particle 1 is going towards 2, and 2 is going this way towards 3. 3 is going away from, and the 4 is going towards first. So this is called the everyone is approaching the other. So if I take any two part points, like what is the V approach of 1 and 2? Like how at what rate they are approaching each other? Just think of two particles, don't think other. What is the V approach here?
V1 minus V2.
What is V minus V2? Everything is V here.
Sir,
I'm
0.
asking you.
So because all have same velocity.
What is V approach? Go by definition, not by your own emotion.
So V approaches V itself.
Correct. V approach is V only. Now, this is the realization. You need to understand what we are trying to explain. So don't try to create your own definition. Just follow the definition. You will understand it.
V minus V2.
See, the major challenge of learning is the difficulty to listen to someone. You know, as the generation is progressing towards newer things, they are losing the ability to listen. So they are more vocal. So I said in the past, like nowadays we have more mouth and less ear. So now let's say if this is a regular hexagon and every vertex is representing a particle. Every vertex is representing a particle, and every particle is trying to move towards the other particle. This is a very common situation of approach question. If I choose any random two particles, 1 and 2, let's say, so what is the V approach between 1 and 2? It's a regular hexagon. So all angles you know what should be done.
Sir, is it V by 2?
It is V by 2. Yeah, I think that's the right answer.
So because internal angle is 120 degrees, so V minus V cos 120 degrees.
Okay. Okay.
Sir, no, it will be 3V by 2.
No, well, this is going away, right? This is 60. So definitely the V cos 60 will be going away from the line joining the particles one. So the V approach is definitely V minus V cos 60.
Yes, sir.
Okay.
Sir, but if we want to find the separation between like 1 and 3 or 4, like
Now you can do this. So let's say this is 3. So then you need to join these two particles. So whatever you want, that's a nice question. If I want to 1 and 3, then now think of the angle from this line to both the particles. So now you will realize that what is this angle. So do you know what is this angle? So this is the isosceles triangle. So this is 120. Both are 30 degrees. And because this is 120, this must be 90. So of course the V will have no component, but this V will have component V cos 30. So V approach between 1 and 3 will be V cos 30. That's it, which is root 3 V by 2.
okay, sir.
It is clear? So you can do a lot of practice there. If you have a triangle, and you can in fact generalize to the in general n polygon, n sided regular polygon. Taking three. So here we have three particles. This is a very famous question called the three and theorem. So one is going towards two, two going towards three, three going towards one, all with velocity v. So what is the v approach here?
Sir, of 1, 2, 3, 2, 3, which
Yeah, just find any two because it's the same every.
sir,
So
V
what is
by
v?
2.
No,
Sir, it's root, no, no. Sir, 3V by 2.
yeah, it's three v.
So 120 degrees because it's
Because it is because no, this is coming this way, na? So you can just take the component. Common sense. You guys don't have this. Okay. So now the both are approaching actually, so we can just add the velocity. So when one is going away from other, we separate. When both are going towards each other, we add. That's common understanding. Okay. So the next step is okay. Something we need to realize now. Something very interesting. So let me draw one triangle again. That's very famous example. this is also called the three ant column. So every ant is approaching the another ant in an equilateral triangle. So we have three ants. The first ant is going this way. The second ant is going this way, and third ant is going this way. They are trying to. They keep on chasing each other. Like they keep. The aim is to chase the other party. So if I say 1, 2, and 3, what happens? Like after some time, the one will be somewhere here. Let's say I'm taking a very small time dt, and 2 is here, and they will travel by the equal distance. So if you join the new line, so the side of the triangle will shorten by the same value. So what we can say about this new triangle? Is it equilateral? Yes or no? Is it going to be equilateral triangle or will it change?
So no, it will be equilateral.
It will remain equilateral actually. Why? Because every dimension will shrink in the same fashion. So the triangle will reduce the size but not the shape. The shape remains preserved. And very next moment, things will go like this. I'm just drawing in a discrete form, although it's a continuous method. Even this new triangle is equilateral. No need to worry. This is for sure equilateral. So you may feel that okay, this should not be the case, but that's not. Now after some time,
So this question came in exam, but it was a square.
pardon, again you can keep on doing this. And you can keep on drawing.
So displacement would be from the center to the.
Yes. Eventually, because of symmetricity, the all the three particles will collide at the center, technically or theoretically. Please. And in this way, eventually, I mean, I can just draw a line. Eventually, they'll meet. Now, before they collide, they will make infinite rotation. Now, that's difficult for you to understand and imagine. Now, this path is called a very interesting path. This is called the spiral. So, the path traced by each particle is called a spiral. And because of symmetricity, they meet at the center. And when they meet at the center, the separation will be zero, right? So now, if I say the side of the triangle is A, so they started with what separation? A. And when they will collide, what is their separation?
Zero.
So the question is, after what time the separation becomes zero? So we know the definition that V approach is minus dl by dt. And therefore, the dl we can write as V approach into dt, right? So if I integrate both sides, so the initial gap is A and final gap is 0. But here, luckily, the V approach is constant value. Why? Because they all remain on the triangle, the same triangle, equilateral triangle. Therefore, if they maintain that triangular shape all the time, So V approach in this case will always comes out to be 3V by 2 as we calculated here. Look at this. Because this answer has nothing to do with the size of the triangle. It has to do with the shape of the triangle. The angle matters, not the length of the side, right? So if you realize this fact, you can see this will become A, this becomes V approach outside, and we have just dt. So the A becomes V approach into time t. And therefore, the time in all question in which V approach is constant, we can just write the initial separation upon V approach. So time to collide, time to meet will be initial separation upon V approach, and that's the question. And so for this case, the answer is A upon 3V by 2, which is 2A by 3V. Okay. Now, not only this, if you take the any question like you can take hexagon or this, here T will be how much? Only A by V, that's it. What is T here? 2A by V, right? See, it's how easy it is. What is T here?
Yes.
2A by 3V. So as long as you are maintaining some hexagon or any polygon, then this will maintain. Like you can do it for any n-sided regular polygon. So for n-sided regular polygon, you can generalize the formula like this because the polygon of n side will have some angle. We call this angle as 2 pi by n, the extreme angle, and the particle is 1 and 2. Gap is a. So one will go this way with V, and two will go this way with V. So what is the V approach here? It's V1 minus cos 2 pi by n, because one is going away, right? And so T will be A by V1 minus cos 2 pi by n. By putting the different value of n, we get all answer which we have derived so far. Understood? So
Yes,
by
sir.
putting the n value, you will get all other values of time. And now we are left with the last question, which is from IE Ruler. That's called the chasing problem, okay, of rat and cat, or the rabbit and tortoise, hare and tortoise. What you can name? Tom and Jerry problem. Okay, I say Tom and Jerry. So okay, so this is a very common thing there. Tom is always trying to chase Jerry. Okay, but Jerry always normally outsmarts in the Disney Tom and Jerry show. But okay, let's say the Tom has his day today. So how the journey starts? So let's say these are two mutually perpendicular actions. In the beginning, Jerry is here. Totally unaware that Tom is here. Or let's know that Tom is bigger. And Jerry is going in this direction without knowing the fact that he is being chased by Tom. So now in the beginning, this is the situation. After some time, okay, and now Tom can really move faster. This is what I'm assuming, and that is also the case. If Tom is moving at a speed v, now after some time, what will happen? The Jerry will be here. Tom will be here, so you can make a, you can join the line, maybe something like this. Then after some time, you can join the line something like this. I mean, just I'm doing randomly. Then just you can play with colors, and eventually it will catch somewhere. So the path that you can see or you can at least feel So the Jerry is moving on a straight line, but how the Tom is moving? So this is
Spiral.
essentially a spiral path. Okay. Because the Tom is trying to always chase the Jerry. So the direction of velocity of the Tom is always towards the velocity, towards the line joining the Jerry. So if you are here, if the Tom is here, I can say for sure Jerry must be here. Why? Because the Tom is always aiming towards the Jerry. So this is the Tom. So the velocity of the Tom in this particular situation must be like this. And this will make some angle. Let's say it makes some angle theta with horizontal. So I can extend this line. This is also theta. At any instant, let's say at time t, you are here. At any instant, this is the L length separation. Initial separation is L. So what is the V approach here at any instant? What is the V approach? Tell me.
Yes.
What is yes? I'm asking V approach,
Sir,
not
it's
E.
V minus.
Mhm.
So one.
बिल्कुल सोच के बोलो कि you take your time, think about the concept, and from there you derive the answer, you get the answer.
So V minus U cos theta.
Yeah, correct. So it is V minus U cos theta for sure because V is already along the line joining the particles, but U is not. So we need to take the component. Now this V approach, we can always now here. If you look at the situation, the theta is not the same at every instant. So theta is a variable. Do you realize this? I hope so.
Yes, sir.
So now we can add as minus dl by dt because that's the definition is how much v minus u cos theta. I am assuming that okay, if you look careful that who is traveling more in a given time, Tom or Jerry, of course. So the catching is only possible that when v is more than u because in the same time when you will catch, the Tom has to travel more than Jerry would have traveled, and the catching will only occur on which line? Line of the Jerry, right? So maybe somewhere here you will catch because Jerry is continuing in the same line. So eventually the Tom will reach the same line and will catch. So dl by dt we can write as v minus u cos theta. So what is minus dl? V minus u cos theta dt. Now integrate. From where to where? Let's say 0 to time t tau. So tau is the time to catch. And the dl we can write as initial separation to 0. So what we get from here? L equals to. Now this is something interesting. We cannot integrate because the first term is okay. We can integrate v dt because v is constant. But the second term is difficult or impossible to integrate. Why? Because theta is a variable and the relationship of theta and t is not known to us. So we are stuck with only one part of the solution. We can just write like this and the rest will leave. So let's call this as equation 1. Somehow we have to evaluate this integration by some indirect means to actually solve this problem. Now, from where that answer will come, it's easy, not difficult. We know that when it will catch, then the distance traveled by the cat, let's if I call x-axis. So I think the x cat and the not cat, it's bad. The x Tom must be same as x Jerry. So whatever the distance the Tom has traveled, but in the x direction, both have traveled same value, isn't it? Because they started from here. So what we can say that the displacement of both must be same at the time of catch. Do you realize this? So what is the x term? How we connect the x term? So we can say v x term, which is v cos theta into dt integration from 0 to tau. This must be same as x 0. What is x 0? U tau because it's constant. And therefore, v is constant, we can take it out. So we can say that cos theta dt from 0 to tau must be u tau by v. Now that's equation 2. Although I was not knowing the integration, but we know what this will be equals to indirectly. So from 1 and 2, we can write L equals to v tau minus u into u tau by v. And this gives you the answer v square minus u square by v into tau. The time after which it will catch is vl by v square minus u square. That's the answer from and question from Kiroda. And this is the end of the kinematics. So congratulations to all of you. We have finished the first chapter of mechanics called kinematics.
Sir,
Okay. Yes.
sir, why we took x term as integration of v cos theta dt? 0 to tau.
What is the x component of Tom velocity in general?
So it is v cos theta.
And how to find the x displacement? X velocity into time
Yeah, sir.
for a small interval, dt interval, and then we integrate to get the net x displacement. And we cannot integrate because cos theta is unknown. So we can take a v outside, and the left we can write as in terms of something else. So this gives you the opportunity to replace this term by something known to you, and that's how we have solved. This is the difficult and most challenging problem of relative motion called velocity of approach problem. Okay. So with this concept, this entire kinematics we are completing here, and the next lecture will be the Newton's laws of motion. So we are entering into dynamics. Okay, kinematics is over. Bye and take care.
Okay.